weight in terms of the probability of match, and the vertical axis is the accuracy. So in this particular case, there are about 220 subjects in the database. And of course, ideally, what you would like to do is recognize everybody at rank 1. That is, the correct person is always identified with the highest matching score. So the bottommost curve, the blue curve, shows when we don't use the model, 3D model. We just match the side viewpoint of the person to the frontal viewpoint in the gallery. And in that match, the rank 1 accuracy is only 30%. Okay, that is the highest matching score for the correct person is found only 30% of the time. When you use the AAM and the morphological model, then you shoot up to the red curve where you have 70% rank 1 accuracy. And if we actually had as the probe the frontal viewpoint, then matching a frontal viewpoint to the frontal gallery accuracy would be much higher. So the model is providing some information, but the model is not completely fixing the problem, because fitting the model is not always perfect. It introduces some distortion, and so that's why we don't have what we would like is the red curve to go to the purple curve. So here's just some example of frames in column A. They were not correctly matched with the gallery in B, but after we do the modeling and generate the frontal view from the video sequence, then all these 1, 2, 3, 4, 5, 6 subjects in the probe were correctly matched to the images in the gallery. So the gallery contains just one frontal viewpoint of the person, and then the probe contains multiple non-frontal views of the same person, and you build a 3D model, generate a frontal viewpoint from that, and then do the matching. So one thing I must point out is that we don't write our own face recognition system, because there is a fairly mature face recognition systems available, and so all these results are based on the system by Cognitech. So Cognitech is a German-based company, and in many of the face recognition competitions, including the NIST competition, it ranks consistently as number 1. So what we have is we have their SDK, and anything which we do, we build it on top of the Cognitech SDK. And so this way we don't have to spend a lot of our time in writing a competing code, and we know that we'll never be able to beat Cognitech, which have been working on this for several years and with several man-years of effort. Another important problem which has not been solved, I'm just illustrating this, and again, keep in mind that what I'm talking about is just research ideas which are still, graduate students can still work on, because these are all important problems and there is no perfect solution which is available in this topic. Is to how do we identify a person at a distance? I mean, this is both challenging academically as well as has many special significance in terms of applications. So there's use of something called PTZ cameras, pan, tilt, and zoom cameras. So the idea is that first you look at the whole scene, identify a person, and once you identify a face, then you use the PTZ camera to zoom in and get a closer viewpoint, and that getting a higher resolution face image then will improve the performance. And that's what this is showing, that the person is maybe about, I would say 8 meters away from the camera, and then the pan, tilt, and zoom gives a higher resolution image of the face, and then that leads to a better accuracy than if you just use the original face image. So next I want to talk about the age modeling, and this is the work which we are currently doing. So there are two problems here. Is how do we improve the face recognition performance when there's a substantial temporal difference between the probe image and the gallery image? And the other challenging problem is how do we estimate the age? And there are many potential commercial applications of age estimation. One of them is people are talking about having vending machines which will dispense alcohol or some other things where you don't want to give the alcohol to the minors or people who are below 18 or something. And so can we have a camera on the vending machine which will estimate the age, as an example. There are other related applications, not necessarily related to the age, because I got a phone call from IEEE Spectrum, which is trying to write some article on a commercial product. That on the billboards where there's a company has some commercial there, they would like to know who is watching that billboard, and if they can estimate or what is the gender and ethnicity of the person is, then they would like to somehow modify the advertisement based on the characteristic of the viewer. Okay? I mean, these are some potential applications which people are looking at. I'm not sure if you know that when there is a television programs, there is a rating done on which programs are more popular and so on. So there's a large company called Nielsen, and this Nielsen rating is one of the most well-known ratings of television programs. And usually, this is digressing a little bit, but you may find it interesting. Nielsen usually enrolls about 20,000 families in the United States, or 20,000 households, and they give them special equipment. They say they don't pay them anything, they're volunteers, but they give them some gifts, coupons or something. And they want to keep track of who is watching which program. And right now, it is done using some special code and clickers. They have the family members who are watching it, they have to push some buttons. But that's always, if they forget to push it, they don't get the complete data. What they would like to do ideally is to have a camera on top of the television set. Okay? So they know who is watching a particular program and how many people are watching it in the family. Okay? That's a very difficult problem, but it has many important applications, right? I mean, it probably is okay if one person is watching it, but if 3 or 4 people are sitting on a sofa or a couch, huddled together, it becomes a more difficult problem. If the lights are dim or the room is too bright, then it becomes a difficult problem. But I'm mentioning to you about a real application. If you have a system like that, Nielsen will pay you a lot of money, and Nielsen is not a small company. I visited them 2 months ago. They have a huge campus in Tampa. But these are some potential applications of face recognition. There are many other applications for elderly patients in a room, in a house. How do we keep track of whether somebody needs urgent care if there are surveillance cameras inside the house, not for robbery detection, but for detecting if some elderly person fell down and cannot reach the telephone, or in a hospital, as an example, critically ill patients, monitoring them using a video surveillance camera. Anyway, our job in this case was can we improve the face recognition accuracy by modeling the aging process to some extent. Okay? And again, as I said, we didn't write our own face recognition algorithm. We just took the cognitive system and see if we can add something to it in order to improve the performance. Now, when we first started looking at it, well, where are we going to get the aging database? Because if you have to build an aging model, you need a database where you have multiple images of the same person available at different ages. It turned out somebody actually provided this database, and this is available in public domain called FGNet database, and it has 82 subjects with a total of 1,000 images, on an average about 12 images per subject, taken at different ages. Okay. Now the problem is that, and the age varies from 0 to 69. By 0 I mean less than 1. Now